Okay, so now we're gonna move on from the concepts and we're gonna start doing some guided practice. Okay, so before we start, I'll first ask you to just recite some of the equations. So I'll just say like, tell me the equation for kinetic energy, and then you'll tell me. So let's start off. So what is the equation for kinetic energy?
Is it 1/2 mv squared?
Yeah, good job. So now what is it for potential energy?
Mgh.
Yes.
Yeah.
What is it for work? Now for work, there's two equations that I taught you. So
Yeah. So one is basically for linear. It's just fx cosine theta, I think.
yes,
Yeah. And then for the integral part, isn't it like integral of force in terms of x?
yeah, f dx.
Yeah.
Good. And now what is the last one that I told you? I'm not gonna say it, you have to tell me.
I remember the equation. I don't remember what the equation is for. Is it for force?
Yeah,
I think isn't it like du over dx?
close. It's negative du over dx.
Oh, okay. My bad.
Okay. So that's pretty much all the equations you have to know for this unit. And so now let's move on to more question answer type stuff. So
Sure.
this is the first question. And so the way I wanted to do it is so I want you to first attempt some of the questions, and then if you're struggling, then I can help you out after that.
Sure. Okay, can we? So I think for a way to solve the potential question could be to use conservation of energy.
Yeah.
So since there's height and velocity, I would say initial kinetic plus initial potential is equal to final kinetic plus final potential. And since it's asking me to find the speed, which is basically the velocity, I know I'll have to equate v final in the kinetic final equation, which is going to be 1/2 mb final squared. So if possible, could you write out basically like the equation? So it'll be 1/2 mb initial squared. And then if I think the initial height is h, right?
Yeah.
So plus mgh is equal to 1/2 mb final squared. And then final potential would be mgb.
Or it's actually point, it says a height above point B is half of h.
Oh, so half of h, my bad. Yeah. So then like you could, since it's basically based on variables and there's not actual numbers, this is like not too bad. You could just simply isolate v final, which
Actually,
would,
one thing you might have missed while reading the question is that a box of mass m is released from rest.
so okay, then initial kinetic is not even a thing, I guess.
Yeah, so this is just zero, so we can just eliminate this from the equation.
Sure, yeah. I just have a quick question.
Yeah.
Uh, Actually, wait, never mind. I do get it. Yeah. So now for this question, then we could just simply isolate v final. So it'll just be mgh minus mg 1/2 h times 2.
Times 2.
Because we're isolating v final, right?
Oh, yes. Yeah.
So times 2 divided by m square root. And m get canceled basically.
Yeah, that is correct.
Yep.
So then we are left with, if we just simplify this really quickly, root gh.
Yep.
This is correct.
Thanks.
Okay, so now part B. Find the speed of the box when it reaches point B. So now this is at the bottom of the hill.
Oh, therefore, I guess we could kind of use the same way, isn't it? Yeah, we could use the same way, right?
Yeah, we would do a similar method to solve this question.
We could use conservation of energy again, but the only tricky part I would say in this part is now for initial potential energy, would the height still be h?
Yeah, so the thing with energy is it could be a bit confusing, but theoretically, for this question, you could take the starting point as anywhere. It could be here, and we could use the same stuff. We could use this as the velocity, and so we would have kinetic plus potential energy. But we could also start at point A where there's only kinetic energy, and it would always turn out to be the same thing because of conservation of energy. So in this
So
question, it would be
yeah,
from point A because it just
yeah.
simplifies the equation.
So at point A, I guess there would be no kinetic energy considering it's at rest. So we can just straight away say mgh is equal to, yeah, me final.
And
Yep.
mechanical energy. So yeah.
So it'll be mgh is equal to, wait, won't there be kinetic energy at the bottom though? Or is that what we're trying to find?
There will be kinetic energy at the bottom, but there'll be no,
Potential.
yeah, because it's
So
on
just be,
ground level relative to the top.
yep. So therefore you can say 1/2 mv final squared, I guess.
Yeah, that is correct.
And then like the first question, we could simply just isolate v final to find the final speed. So yep, v final will just equal the square root of 2.
Yeah.
Yep.
Okay, good. Now part C. Now this one can be a bit harder. So just let me know.
The box comes to rest at point C.
I haven't done
So
it.
since I'm trying to find the coefficient of friction of kinetic, is that of kinetic friction, I guess. I would say you cannot use. Wait, you could use you could potentially use conservation of energy, isn't it?
Yeah.
But you just have to take into account that that there is frictional energy,
Or it's not really frictional energy. It's more
frictional force.
force doing work.
Yeah.
And so since you mentioned before it's kinetic friction, right?
Yep.
Box will be moving through here.
Yeah.
Because of this work done by the kinet or because of the
Final velocity would be 0.
or yeah, friction, it will slow down the box and it'll eventually stop at C.
Yeah. Okay.
Of friction that would do that.
Yeah. So I think maybe, I mean, we could use conservation of energy, I guess, again.
Yeah. But
So
use the different version of the equation.
yeah.
Any initial plus work.
Yep.
Any final. Because in this instance, there's work, but in the other two, there's no friction or air resistance or anything, so there's no work being done on the block.
Yeah.
And so then where would you go from here?
So the way I was thinking, I'm not sure if this is correct. It might be a bit different than what you wrote down, but since we know before it actually before basically initially the box has velocity v final, which we found in part B, right?
Yeah.
We couldn't we just say 1/2 m 2gh square mv squared? That's the only energy at that point is equal to kinetic energy. We want it to be 0, therefore velocity would be 0, therefore minus frictional energy.
Yeah, so the way this would work is that at the end, we want mechanical energy final to be 0, right? Because we know it stops and it's at the ground level, so that would be 0. And so then if we just rearrange this equation, it would be minus work, which is, I guess,
Okay. Yeah. But then where would the mu be for us to find? Would it be in part of work? Because work is equal to ft cosine theta?
sorry, could you say that again?
How would we find where would the coefficient of friction be in this equation then?
So let's think about what work is. Work is FD cos theta, right? As we mentioned before. And so in this instance, the force is frictional force.
Yeah.
Be FF d cos theta.
Yep.
When you simplify FF, what do you get?
Mu n.
Mu Fn, yeah. And so then that's where you get the mu from. So we would
Oh,
go
okay.
H equals negative mu Fn, and cos theta would be cos 90. So
Yeah,
cos 0, so it would just be 1.
Yeah.
That's irrelevant, so we don't have to write that.
Mhm.
So now,
Then
so what is Fn equal to?
Fn is just equal to, I guess, Fn is just equal to mgh over mu, but like that's not what you're asking for, I think. So Fn I can write as mg, right?
Yeah.
Therefore mg get cancelled. So technically at the
Yeah, so we just made one mistake. I was hoping you would catch it, but I'll just let you know. So we forgot the times x. So let me just remind you, work is f times x times cos theta. And so
Yep.
you include x, which is actually given in the question as well. There's the distance of x that it covers before stopping. And
Yeah.
so the equation would be here as well.
Yep.
Now when we simplify it, we get mu equals,
H over x.
and that is our answer. Good
I just
job.
have a quick question. It's a bit conceptual question. I think we covered this like previously, but I think I'm not, I won't say I'm like 100% comfortable with it, but could you just explain why why is it plus work? I don't understand that part.
Yeah, and so work is
Changing that.
okay, so that's actually a really good question. A lot of people get confused why work is involved in the equation. And so basically, let me explain to you what work is in a more general sense, not just the physical equations and stuff like that. So work is basically the change in energy created by forces in the environment. So in this case, the force acting on the block, creating the change in energy on the block is the frictional force. And so essentially we're adding the energy provided to the block by the environment. And now in this case, we know that the work done is negative because the frictional force is going against the motion of the block. And because of
Oh,
that, it is subtracting from the kinetic energy. So the delta KE, which we said work equals, let me write that down above again, because I think there's a bit of confusion on that as well. So this work is also delta kinetic energy, right? And so in this, as we can see, the block is slowing down as it passes through this range.
mhm.
So because of that, the delta KE is negative.
Yeah.
And because of that, the work is also negative, which is
All
shown
right, all
in
right.
these equations. But on the other hand, if there's a force of wind pushing it that way and there's no friction, then that force would provide work onto the block in the positive direction.
Therefore, the box would be speeding up.
Then delta KE would be positive, work would be positive, and you would add that to the mechanical energy initial. So then your
Oh,
final mechanical energy would be higher.
so yeah, so I think I get it now. So you're basically saying whenever the energy acting on a box is affected by an external force on the environment, which in this case is friction, you have to take into account basically work, and whether the work is positive or negative is dependent on basically whether it's adding energy, not adding energy, however, if it's positive or negative at the end of the day.
Positive or negative is adding or sort of,
Subtracting energy.
yeah.
Okay, understood.
Okay, and so now, do you understand part C? Should we move on to part D?
Yeah,
Okay, so part D is a bit more difficult. Let me know if you need help. I could also help you draw a diagram for part D if you need that.
got it. Oh, I think I understand. Yeah.
Okay, so
So
we should start off this question just quickly by drawing a diagram before.
yeah. So basically, instead of being horizontal from B to C, it's kind of gonna like go like a hypotenuse.
Yeah,
And
exactly.
then
So it would kind of go like this, right?
yeah.
And now what would this length be?
I think it's at Y.
Yes. And then just to help, we can name this angle theta.
Yeah.
And so what would the length of this length here be, the slant?
Sorry, which
What would
one?
the length of the slant here be?
The length of that you can say is going to be Y sine theta.
Yeah.
Yeah.
Or you could also write it as square root of x squared plus y squared
Yeah.
if you were to use Pythagoras.
Yeah. Oh, yeah, because that's still X.
Yeah.
Actually, wait. I have a quick question.
Yeah.
Isn't the hypotenuse technically X? Oh, wait, no, that's a wait, my bad, my bad.
The horizontal is x still.
Yeah. Okay.
Okay, so then how would you approach this question?
So what I'm thinking now is the fact that we could kind of use a previous equation, but in the second part of the equation, we have to take into account the potential energy at the end, considering there is a height and potential energy to change. So I would say it's going to be mechanical initial energy plus work again, because it's negative, is equal to uh final kinetic energy would still be zero, right?
Yeah, because in this question, it's still stopping once it reaches.
Yeah. And then, but like there is potential energy, therefore we have to say MGY, I guess.
Or I think if you're writing ME initial, let's just finish this off with ME final and then break that
Yeah.
down again.
Sure.
So it's more uniform.
Yeah.
So as you said before, what would the initial mechanical energy be?
Initial mechanical, so potential energy would be 0.
Yeah,
And initial kinetic energy would be 1/2 m square root of 2gh squared
yeah.
plus work because
A thing about that is actually, so this, when you substitute root 2gh into it, right?
yep.
You square, it actually simplifies to mgh,
Okay, yeah. Oh, because yeah, makes sense.
potential energy here.
Yeah.
And so that's a cool thing in which you could take it from here, here, or here, and it would all simplify to the same thing.
Yeah. Shows conservation quite well.
Yeah, so we could write mgh.
Yep.
Now, what would the work be in this case?
Work. Uh, I mean, work. It's since it's still being caused by friction, which is the external force in this environment. Wouldn't it still be mu Fn?
Yeah, so it would be negative mu Fn. But there's other parts of the work equation, remember?
Oh, it's at a theta now, basically.
And
So,
one more part that we actually forgot last time as well.
oh, change in x, my bad.
Yeah, and so in this case, let's write root x squared plus y squared. And now that it's at a bank, it's on an angle, so we also have to incorporate cos theta.
Why is it negative now? When we wrote work is positive above, shouldn't we technically write it as positive in this part of the equation, and then when we move it to the other side, it becomes negative?
Yeah, so earlier, this should have been, so it should be written like this, because since the work done is negative, but this is just the mathematical equation, so when we're rewriting,
Oh,
it'll be negative on this side, just by basic algebra, like if you take.
okay, understood. So right now I could basically write this as plus and then in parentheses negative mu Fn.
Yeah, do you want us to do that? Because I'll send you these notes later, so if you want it to be more clear.
Yeah, if you could, because I think it's just for conceptual reasons.
Yeah.
Yeah.
And so now, what does this equal? What's the final energy in this situation?
Final energy would just be potential energy, I guess, because velocity is 0 at the end, so it'll just be mgy.
Yeah, that is correct.
Yeah, and then again, like then it's kind of like simple algebra, I guess, and then you can just solve for mu again because that's what it has to do.
Yeah, but I actually want you to help me simplify this part. So it'll be mgh minus y equals mu times. So what would Fn be in this case?
Fn would be mg sine theta
Are
or
you,
cosine. Yeah, cosine.
yeah, it is mg cosine theta.
Yeah, cosine theta. My bad.
On that sometimes.
Yep. So mg cosine theta times square root of x squared plus y squared times cosine theta is unknown, right? In this equation, I mean the question. I mean.
Just give me a second.
Sure.
Yeah. Okay. So now there's one thing that's a bit confusing here. This cosine theta from the work equation is actually turning out to be 1. And that is because the block here is moving in the same direction as the forces applied onto it.
Yeah.
Simplifies. That is not to be confused with this theta, which will later apply when we're solving for Fn.
Yeah. Makes sense.
So we can just quickly cross that out because it'll just be 1.
Sure.
If we simplify this again, h minus y equals mu times mg cos theta times root x squared plus y squared.
Yep.
Right.
And then we can, I guess, just divide mg cosine theta square root of x squared plus y squared.
I actually want you to get rid of this cosine theta. There's a way you can simplify this some more.
Well, first things first, we could cancel out mg, right?
Yeah, let's do that first. So mg is gone. Now we're left with h minus y equals mu times cosine theta times root x squared plus y squared.
Yeah.
Yeah. So now let's think about what cosine theta is. So if we go back to the question, could you tell me what cosine theta is in terms of the variables?
I guess it's x over square. Oh, so you're saying you could basically cancel out that x squared plus y squared.
Yeah. And so that just simplifies the equation a whole lot more and makes it a lot more
Oh.
confusing. So we get h minus y equals mu times x over root
Square root of x squared plus y squared.
y square times root x squared plus y squared. And now these two will cancel. And so now mu is equal to
H minus y over x.
okay. So now let's just try one more question. This question has a bit more of calculus in it. And so, yeah. And so this is just a different type of question that you'll get. You'll probably get one of these two questions on your test or something like that. So these are the types of questions you should be able to practice and learn more. I'll send you more questions like this after the class.
Yeah, sure.
So let's try this question. Just go ahead and read it.
The force on a 6 kg object is given by the equation f of x is equal to 3x plus 5, of course, in newtons. The object is moving 2 meters per second at the origin. A. Determine the work done on the object by the force when it's moved 4 meters from the origin in the positive x direction. So what I'm thinking is, I know work is, the second equation for work is integral of f dx.
Yep.
Right, and I know the equation for force in this case. Therefore, to find work, I can technically just find the integral of the force equation, which will just become 3x squared over 2. 3x squared over 2 plus 5x plus c, of course.
Actually, in physics, you don't have to include the plus c.
Are you sure?
This is experimental values.
Oh, understood. Yeah.
And so it's sort of like simplifying an integral when it's a definite integral.
Yeah, okay.
It's just going to develop a general equation and then substitute the values in later.
Sure. So then,
how you would do it.
yeah, and then you can just plug in 4 for x, I guess.
Yeah, so w of 4, because it moves 4 meters from the origin.
Yep.
So actually, the correct way to write this is just a faster way, but it would be from 0, because that's the origin, to 4.
Yeah.
And so that's why it's a definite integral. So let's write it that way, actually. That is better for your understanding.
Yeah.
And so now if we simplify that, just tell me what we get when we plug in.
So you get 24 plus 20, so 30, 24 plus 20, so 44, I guess.
24 plus 20, yes, you get 44.
And
what
the unit
for this
is, so wait for it. So work is equal to joules per meter.
plus joules.
Oh, that's the one.
Okay,
That always gets me.
That is the work done on the object by the force. And so now let's move on to part B. Determine the speed of the object when it is moved 4 meters.
The speed of the object.
And so let's think about what the equations of work are again. We've one, and there's one more that has something to do with speed.
Change in energy?
Change in kinetic energy.
Change in kinetic energy.
So let's write that out. Work equals delta KE. And so now we know what work is, right?
Yeah.
44 joules equals, and then what's the equation for changing kinetic energy?
1/2 m v final minus v initial.
V final
minus v initial.
Just one thing is missing from that.
Squared.
So it's actually not the whole squared. It's actually v final square minus v initial square.
Ooh.
So that's a common misconception. Like, I'll just show you what happens if you do v final minus v initial squared, right? So it'll come out to something else. It'll come out to 1/2 m vf squared minus 2 vi vf plus vi squared.
Yeah.
Which is not what we're looking for, because this is actually a simplification of 1/2 mv final squared minus 1/2 mv initial squared. And so, as you can see, these two things are just not equal.
Yeah, makes sense.
Okay. So now let's continue on with the question. So how would you go on from here?
So when it says when the object has moved 4 meters, I know work is equal to 44, so 2 to 88 is equal to 6 v final squared minus v initial squared. So I can basically simplify the equation to 8 is equal to v final squared minus v initial squared.
So let's write that out in steps.
Sure.
First, you would do 2 times 44, right?
Yep.
So 88 equals m into what is m?
6.
V final is what we're finding. And
Yep.
what's the initial?
0.
It's actually 2.
Oh, 2.
The object is moving at 2 meters per second at the origin.
Yep.
So let's do -4. And now we can simplify this some more. So it would become
Right. It is basically divided by 6, 1, 2, 8.
So I think it
So-
will come to a decimal.
Yeah.
So let's just write it in terms of fractions. So it would be
Sure.
88 over 6
Plus 4.
and
Square
so
root.
VF equals the square root of that.
Yeah.
Okay, so I think you need a little more work on the work equations.
Uh,
So I think that would be one main practice point. I'll send you these notes that we did, both the conceptual notes where I went over the concepts and equations, as well as this worksheet, just so you can reference while you're doing future questions.
sure.
I'll also send you some more questions from multiple textbooks and packets that I've found online.
Sure.
If you have any questions, feel free to contact me through either WhatsApp or any other social media platform that we're both on.
Sure.
I would highly encourage you, as I said before, to just review the work equations, because I've basically taught you 3 different work equations, and so sometimes you can get a bit confusing on when to use which and how to use each. And so I would highly recommend you use those and practice those.
Got it.
If you have any other questions,
I think I know. I think I understand most of it. Yeah, I got a bit confused in the middle, but like I think after the explanation, I'm pretty clear on how I could approach different types of questions.
yeah. Okay. So if there's nothing else, I think we can wrap up the session here.
Yeah.
Thank you very much.